this final example for section 1.4, I've got some fractions involved. And don't get too scared when you see fractions. We will be seeing them throughout the course, and they show up in a lot of different ways. Sometimes there's variables in them, sometimes there's not. In this case, there are. The variables are on top, so that makes this a little bit easier. Most of the time when we see fractions in an equation, we'll be able to eliminate those fractions fairly quickly. Okay, so it's not, you don't have to keep them in there that long. There are many approaches to solving this problem. There's ways to split these fractions up and get common denominators and work them out that way. But there's other quicker ways that we could get rid of the fractions and not have to work with them throughout the problem. I'm going to show you that method here in this video. Although if you were comfortable using the fractions, you could do a variety of other approaches to solving this problem. Okay. So what I'm going to do is I look at the denominators here, the 3 and the 8, and I think, what is a common denominator? What is the least common denominator? Okay. And the answer to that is 24. 24 is the smallest number that is a multiple of both 3 and 8. Now in this case it happens to be their product. It isn't always that case. Okay. So here the LCD, I'll just write that off to the side, the least common denominator is 24. And so the trick that I'm going to show you to get rid of the fractions is to multiply both sides of the equation by 24, by the LCD. Okay. Remember that whatever I do to one side of the equation, I have to do to the other side of the equation. Okay. So we're using what's called the multiplication principle of equality. So I'm going to take the left side of this equation, multiply it by 24, and I'm going to take the right side and multiply it by 24. Now on the left side I have a sum here. I've got a number and a fraction added together. I'm going to use the distributive property to move that 24 into the parentheses. What I'm going to end up with then is 24 times 5, which we'll deal with that in just a moment. And I'm going to add to that 24 times the fraction x minus 2 over 3. We'll deal with that in a moment as well. On the right hand side, I'm going to end up with 24 times the fraction x plus 3 over 8. I just changed the order. Some people like, it doesn't really matter what order I put those in because it's multiplication. So now I'm going to try to simplify these things. Well, the first term, 24 times 5 is, well, 20 times 5 is, what's that, 100, right? And 4 times 5 is 20, so 24 times 5 is 120. Oops. So let's make this 120. Now, whenever you're multiplying by a fraction, if the two numbers have a common factor on top and on the bottom, you can do some canceling. And so here, if I think of this as 24 over 1, the 24 and the 3 have a common factor of 3. So I can cancel this out, call it an 8, cancel this out, call it a 1. Right? Divide both top and bottom by 3. And so then what I really have is 8 times the quantity x minus 2. Okay, so I've eliminated the fraction from that term. Similarly on this side, the 24, if I think of it as 24 over 1, I'm really multiplying two fractions together. And if I reduce, if I divide the top and the bottom each by an 8, divide that by 8, I get a 3, and divide that by 8, I get a 1. So I'm canceling or reducing the fractions. Okay. Then I end up with a 3, and then multiplying the quantity x plus 3 because the bottoms become 1, so I don't really need the denominators anymore. At this point, I can just go through and use the distributive property where necessary. So we get 120 plus 8x minus 16 equals 3x plus 9. I can combine like terms. 120 minus 16 is 104. And now I want to move my terms around so that I have all my variables on one side and all my constants on the other. I tend to prefer having the variables on the left and the constants on the right, but it doesn't really matter, it's interchangeable at this point. To do this, I'm going to eliminate the variable term from the right side. I'd like to zero that out. And so to zero out a 3x, I have to subtract a 3x, right? So we'll use the opposite sign there. If I do that on the right, I have to do that on the left. And so it will cancel out on the right-hand side. While I'm at it, I could also do the same to this 104. I want to drop the 104 out, make it a 0, so I'm going to subtract 104 from both sides of the equation. On the left, it adds up to 0. So the left-hand side simplifies to a 5x when I combine these. And the right-hand side, 9 minus 104, will simplify to a negative, what's that, 95? Okay. And then to eliminate the 5 or turn that into a 1, I will divide both sides by 5. The 5's cancel, I'm left with an x. And if you calculate negative 95 over 5, you get negative 19, right? 100 over 5 is 20, so it's 1 less 5. So negative 19. And of course, we're not quite done. In all of these equations, when we solve them, we want to write our answer as a solution set. So once again, the solution set will be the set containing the point or the number negative 19.